The biggest AI story today is not another chatbot feature. It is the machine underneath the machine. OpenAI has just unveiled its first custom inference chip with Broadcom, and that tells us the AI race is moving from model releases into the full stack, silicon, energy, memory, networking, enterprise workflows, and trust infrastructure. By the end of this briefing, you will understand today's signal, why custom chips matter, why workplace AI is becoming ambient, why enterprise agents need real runtimes, and why the next phase of AI will be judged not just by intelligence, but by control, cost, and credibility. If you're new here, I'm the AI Orchestrator. I track the most important moves in AI, cut through the noise, and bring you the stories that actually matter. If that helps you stay ahead, hit like, subscribe, and let's get into today's briefing. Story 1. OpenAI and Broadcom have unveiled Jalapeno, OpenAI's first intelligence processor, a custom accelerator designed specifically around large language model inference. OpenAI's own announcement says Jalapeno is designed to be the best inference platform for LLMs. This is not being framed as a general-purpose accelerator adapted for AI. OpenAI says it was designed from scratch around the serving patterns, kernels, memory movement, and networking needs of current and future language models. The company says the chip went from design to production in 9 months, accelerated by OpenAI's own models. Engineering samples are already running machine learning workloads in the lab, including GPT 5.3 Codex Spark. OpenAI also says early testing points to performance per watt, substantially better than current state-of-the-art, with detailed performance numbers still coming later. Why does this matter? Inference is where AI becomes a real economy. Training gets the headlines, but inference is what happens every time a user asks a model to write, reason, code, search, or operate an agent. If OpenAI can reduce latency and cost at scale, that changes product margins, reliability, and access, and the supply chain matters too. MIT Technology Review's new ASML piece describes the lithography machines behind advanced chips as $400 million, more than 150-ton systems. So today's chip story is not just OpenAI versus NVIDIA. It is the physical infrastructure race underneath the entire AI market. Story 2. Anthropic is turning Claude into something closer to an always-on team member. The new product is Claude Tag, starting in Slack. Teams can grant Claude access to selected channels, connect it to approved tools, data, and codebases, then tag at Claude and delegate work. The strategic shift is bigger than a Slack bot. Anthropic says Claude Tag can remember relevant channel context, plan tasks for the future, work asynchronously over hours or days, and, if ambient behavior is enabled, proactively flag relevant information or follow up on unresolved threads. That matters because enterprise AI has been stuck between two extremes: private chat windows that forget the organization, and risky automations that know too much. Claude Tag is Anthropic's answer, a shared AI teammate with scoped memory, channel-level permissions, admin controls, logs, and spending limits. Anthropic also says tagging Claude is now one of the main ways they get work done internally, and that 65% of their product team's code is created by their internal version of Claude Tag. Treat that as Anthropic's own claim, but the direction is clear. Workplace AI is moving from individual assistant to organizational fabric. Story 3. NVIDIA is packaging the enterprise agent stack. NVIDIA's Agent Toolkit is described as an open, modular foundation made of models, tools, skills, and a secure runtime. The company's framing is deliberate. Businesses do not just need access to frontier models. They need specialized agents that can reason, use tools, take action, and operate safely inside real workflows. The pieces NVIDIA highlights are Nemotron open models for reasoning, NemoClaw blueprints for safer behavior, and OpenShell runtime support for agents operating inside business systems. In other words, NVIDIA is not only selling GPUs into the agent boom, it is trying to define the packaging around digital coworkers. The takeaway: enterprise AI agents are becoming infrastructure. The winners will not only have the smartest model, they will have the best permissioning, the most reliable tool use, the strongest observability, and the easiest path from prototype to production. Story 4. AI is increasingly being shown as a scientific collaborator, with all the promise and all the caution that requires. OpenAI published a case study about immunologist Daria Unut-Maz, who used GPT-5 Pro to revisit a 3-year-old mystery in T-cell biology. According to OpenAI, the model suggested that deoxyglucose may have interfered with construction of the protein IL-2, removing a barrier that normally prevents certain T cells from becoming Th17 inflammatory response cells. This is the kind of story that makes AI feel different from ordinary software. The model is not merely summarizing papers, it is being used as a collaborator that can connect mechanisms across domains and suggest explanations scientists can test. Google has a related medical AI signal. Its AMI disease management research, published in Nature according to Google's announcement, moves from one-off diagnosis toward longer-term care planning. Google says that in a blinded study with patient actors, specialist physicians compared AMI with 21 primary care doctors, and AMI matched clinicians in overall management reasoning while scoring higher in plan precision and guideline alignment. The caveat is essential. This is not a license to replace doctors. These are reported research results, and clinical settings require validation, regulation, and accountability. But the direction is meaningful. AI is moving into hypothesis generation, literature synthesis, guideline reasoning, and care plan support. Final story. The trust layer is becoming part of the AI stack. OpenAI announced work around the Appia Foundation, hosted by the Linux Foundation, to develop open, modular specifications for assessing advanced AI systems. The goal is to translate standards and governance frameworks into practical assessment criteria across the AI value chain. A shared technical language for model evaluations, safety practices, and third-party evidence. Separately, OpenAI introduced Patch the Planet, a daybreak initiative with Trail of Bits to help open-source maintainers find, validate, and patch vulnerabilities. The initial participant list includes CURL, NAT server, Pika, cryptography, SigStore, UTTP, the Go project, FreeNginx, Python, and Python.org. That is not a side story. If AI systems are going to write code, manage workflows, operate infrastructure, and touch sensitive data, the ecosystem needs better standards, better disclosure, and better security engineering. Intelligence without trust becomes a liability. So, here is today's signal. The AI race is becoming a systems race. OpenAI is moving into custom silicon. Anthropic is moving Claude into the shared workplace. NVIDIA is packaging the agent runtime. Google and OpenAI are showing AI in science and medicine. And the standards and security layer is becoming just as important as the model layer. The next winners in AI will not simply be the companies with the most impressive demos. They will be the ones that can make intelligence cheaper, safer, more useful, and more deeply integrated into the real world. That is today's briefing from the AI Orchestrator. Stay sharp, stay skeptical, and I'll see you in the next signal.